Well, hello there, community. Today is a fantastic opportunity to learn about the benefits of F5 Distributed Cloud and how better to learn that than a real attack story. Jack Fenimore, how are you, sir?
Hi, Jason. Thank you for having me today.
I am excited about this story. I've heard it a couple times, and our community needs to know about it because you hear things like multi-cloud and cloud services and cloud security and even like F5 distributed cloud, and for a lot of people who have not really dug into it yet, they're like, what are these things, and do I really need them, and what are they going to do for me? And so I think use cases like this that not only show what it is, but then, the result of it being in place, I think will do a world of good to educate our community. And so I'm glad you're here, and I'm glad that we're going to get into this story. So before we get to the walkthrough, what was the thing that really stuck out to you the first time you heard the story?
Well, Jason, I'd say what stuck out to me was, oh man, I don't want to reveal our big ending point, but there's a number of tools in our toolbox that we use to combat bad actors out there and attacks out there. And the tools that were actually useful at the end of the day, that was really what was something that shone a lot of light on the distributed cloud and what it can bring to our customers and how it can help them.
Yeah, I may come back to that at the end of the show because I know why you're not saying it. And so, for that aspect, why don't we get into this?
Yeah, absolutely. So today, Jason, we're going to tell a story about one of F5's acquisitions. As you know, F5, and as our customers know, we've acquired a number of companies over the years, from Volterra to NGINX, and so forth and so on, all the way back to Traffic Shield when we originally adopted and brought in ASM, or Application Security Manager, that later became Advanced WAAP. Well, we protect all of F5's websites with F5 Distributed Cloud. Now, we think that's something that's important. We should be using our own tools there, and we do. But it came to our attention that one of the sites in the F5 portfolio, and I'm not going to mention which one, that it was actually protected by not F5 Distributed Cloud. The company that was originally providing that protection was still in place. And, we felt, especially in the sales organization, that probably really should be us there. So we went down to the IT department, and as the story goes, I was not actually one of the engineers on this, but these engineers, architects, went down to the IT department and said, hey, can we get this flipped over? And much like any IT department, they said, put in a request and we'll look into it next quarter. Now,
I thought you were going to say, no, come back in 90 days.
Yeah, you knew that we knew that was coming, I'm sure, but they, that was that. In IT also had an important point that the site was being protected, just not from the solution we really wanted to be there. And we also feel that it's a better solution, but we'll get into that. So sales took over this project. And as things go, a couple of our solution architects were, I believe the word I heard was voluntold. They were going to leave this project. And on top of that, as I've been informed, they were told that the window that they were being given was Thanksgiving morning. So
that's not a very long window there, Jack. You think, you give like 30 days or even 60 days. This morning, that is not a big window.
No, and on the holidays, not the most ideal time either for the engineers on the project as well. But
no turkey trot for them, right?
No. And I would like to give a quick shout out to Chaz Leahy and Matt Harmon. I believe also Steve Iannetta helped out on this. That's not the complete list, but those are some of the fellows that did the heavy lifting on this. So let's jump in here a bit. What's this slide trying to say? On the left and the right, these columns are showing you all of the components of the distributed cloud that were used to solve the problem. What's the problem? Well, what happens is once they turn the reins of the site over to the architects and they start managing it, exactly what you'd expect happens. The site gets attacked. So we'll get more into that in just a moment. But what I want to show you here on the left and right side are all the different tools like IP reputation, URI routing, malicious user fingerprinting, automatic certificates, rate limiting, and so forth. In the center, that's just a sample placeholder website. As I mentioned before, we can't reveal which property it was, so we're just going to simply refer to it as example.com. So all these services on the left and right were used in combination to prevent a little more trouble that is just ahead here. So here's peacetime for our site, Jason. And this is a couple weeks after we moved into the distributed cloud, around about December 9th. Again, we were simply replacing SaaS infrastructures. One WAF and load balancer for another WAF and load balancer, plus denial of service, of course. Everything is...
And to be clear, you're saying December 9th, but this is, if I'm doing my math correctly Thanksgiving moves around, but probably about, a week and a half to 2 weeks of time, right? From the time that we have converted to, what we're gonna see here.
Yes, you're correct. And your math will be better than mine, I assure you. So we had there's external monitoring set up from a third party, synthetic monitoring through the site to make sure that everything is continuing to work on that site. We'll touch more on that in a second, but the takeaway here is we're running about 75,000 requests a day, and we're running 13.5 or 14 requests per second. That's peacetime for us. Let's take a quick look at the security events during peacetime also, and you see that basically 16% of the traffic is some sort of security event. Over on the right and towards the bottom, we're featuring some of the tools that were in use. So within the service policies framework, we have things like IP reputation, rate limiting, URI path. They don't sound the most exciting, but there's more to that. Also, the web application firewall, always the crown, one of the key pieces of any web defense and protection, and then bot mitigation, both signature-based and telemetry-based. So another normal day, just showing our average requests again at 13.5. And here, things got a little bit exciting about a week later. And we had this event where we went to 14 million requests per hour from 7,500 requests per hour, Jason. So things got exciting.
That is definitely a level of, a power of 2 times a lot, going from, would you say 7,500 to 13.6 million?
Yes.
That's, let's see, 2, yeah. That's significant.
Yeah, it's a big jump. And, first of all, there's a big thank you to the SREs out there, the site reliability engineers, because they're doing all the hard work under the hood to make sure this all stays up. And we can say successfully that our third-party monitoring never noticed any delay in our site. And even more importantly, none of the other customers on the distributed cloud had any idea this was going on. It was just simply absorbed by the SaaS platform.
That's fantastic. And incredible.
Yeah.
And just incidentally, December 14th, that is my dad's birthday. So maybe he got a little attack kit on his birthday and went to town.
Or maybe you posted something on DevCentral about creating attacks, and I don't know, maybe, who knows?
Maybe. That's significant.
Yeah, and speaking of significant, here you can see 19 million security events, up from an average of 12,000 a day. So things definitely got exciting. Since we're post-attack, we can now share that this attack type was a layer 7 distributed denial of service. Over to the right, we're just highlighting threat campaigns. Threat campaigns are signatures designed to have no false positives so that you don't have to worry about going through signature staging. They can take them directly into production. And that's a subscription provided by F5, but it's included in any F5 distributed cloud site. Threat campaigns is included. But for folks interested in that on perhaps ASM or advanced WAF, that is a subscription we can add to that. And that's all those things happening there, the threat campaign signatures and IP reputation, that's all happening prior to the WAF inspection. And these tools had also all been set up prior to the attack. On this
And
slide,
most of that is as I'm deploying my first workloads in distributed cloud as part of Aubrey and my Build It Live series. A lot of that looks like it's checkboxes. Like I'm not really having to do deep configuration and have to have like deep security domain knowledge. It's, hey, do you want to enable this? Yes or no. And not that there isn't configuration for some of it, but a lot of these things are checkboxes, which is kind of fantastic.
yeah, and we've definitely put ASM through a slim fast program, if you will. And when you get in there, it's, do I want to be blocking or not? And I always suggest starting out in blocking mode. Happy to discuss that with anybody. But just in terms of an approach, what types of signatures you want on there? Do you want the bot defense on there, and so forth? I'm not going to iterate through all the options, but there's not a ton of questions, and a lot of things that users used to have to tend to, we're trying to manage with things like machine learning. So especially with false positives and signature management, do we really need as much human interaction there, or can we offload some of this onto the computers, or the compute, if you will? So we're looking at the security events down at the bottom, and you can see the WAF's pretty busy with 46,000 events. Bot defense hits 11,000 events there. But then you realize service policy is M, and it's millions. And remember what was in service policy. That was things like IP reputation. There's a TLS fingerprinting that I'll get into in a moment, falls into there as well. So let's look at this attack a little bit here. And don't take that last slide to mean the WAF wasn't doing anything. It was still processing quite a bit of traffic. And here's a look at what it was doing. Clearly, you can see this was a probing style attack. But surprisingly for this attack, based on the last slide, the WAF was the smallest piece. So it's an indicator to say, hey, we really should consider everything else that's in that toolbox. What else can we use to help out there? And we know from before we had 45,000 events with WAF. Bot protection was knocking off another 11,000 events based on that number. And we had bot defense, or bot signatures, across the entire site. And then we're using the former shape with the telemetry-based bot defense on the login page, or the intelligent bot feature on the login page.
Well, and you think about things like WAF, it's doing a lot. And you said 45,000 events or whatever that ASM or WAF took care of, and it, that might be a small load, but that's kind of fantastic, right? Because it is probably the most compute expensive of all the things in the chain, and so if you can offload that compute from your WAF, then that's why you're not going to see the delays in service that you would if the things further up in the chain weren't handling those loads.
You're spot on, Jason. You're spot on. So let's dive into some of the pieces that are doing the block and tackling up front. So this generally all falls within service policies. So what are service policies? Service policies are where we can apply a series of security measures. For example, tying in the malicious user fingerprint, or tying in IP reputation, and tying in reputation. Under malicious users at the top there, you can see our machine learning-based signatures. We used to have engineers in the Silverline days create these signatures by hand, and that could take a little bit of time, as you can imagine, or take up several engineers for a few minutes to get that done. Now we can do this almost in real time, programmatically. From the fingerprint, we saw that this attacker was changing their IP address hundreds of times a minute, but the fingerprint is looking at all the data that the client is sharing, or some might say leaking out. For example, when you, Jason, go to a website, your web browser happily tells that website your preferred language, your keyboard region, your screen resolution, your time zone, and a whole bunch more information. And frankly, that makes you a lot more identifiable than you might realize. So if your IP address is changing rapidly, it may really not matter a whole lot. And in this case, we were able to use that to help us out quite a bit.
Yeah, I forget which the documentary was. It might have been Terms and Conditions, but they kind of talked about that fingerprinting concept, and that it doesn't really matter that you're using Chrome. It doesn't matter that you're using plugin XYZ in your browser. It doesn't matter that you have a pattern of usernames or whatever. None of the individual identifying components matter. It's the aggregate of all of it put together that allows entities to fingerprint and build that case.
Yeah, absolutely. Jason, if we're allowed to reference third parties in this, I would share that the Electronic Frontier Foundation, or EFF, has done quite a bit of work on this, and the specific project's called the Panopticlick. And if anybody's interested in learning more about browsers and the data that they're sharing or leaking, there's tons of information over on the EFF website and research on the topic there.
Maybe we'll have to have you on DevCentral Connects as a guest to talk about specifically that. That would be a fun show.
So as promised, we're going to look at the fingerprint, the logs there. We have a 100% match on that fingerprint. We know for certain that traffic belongs to that user, and then it's flagged as a high. So that person in particular was one of our big problems throughout this particular attack. On the right, all the way on the right, you can see various identification properties that we're able to use to help identify and classify these bad actors coming in. And based on those, you can take a number of various actions, for example, like a cooling off period. And in this case, just to remind everybody, it didn't matter that user was changing their IP address. We were still able to follow that through. Here is the bot defense perspective, and you can see the spike in traffic during the attack there. Suppose bad actors or suspects down there at the bottom, and the top malicious bots. Here we can see analytics, trends, requests, etc. In this case, we're viewing per origin about 1.3 thousand requests per server. So that's a pretty good load, pretty decent website. Observability. Here's where we show data to help our SREs maintain the site at top availability. You can see response times and so forth on the slide. There's a lot of hopefully helpful information. An interesting aspect is that F5 can help you tune up to an A+ grade on your site by pulling the SSL Labs report down and making specific recommendations for your site's configuration. This was not part of the attack, just to point out a helpful tool here. And you can see in the middle of that report that we are capped at an A because we don't have HSTS turned on. If we turn that on, that should push us up to an A+. But that line's always moving.
Yeah.
that might not be true today, but this slide's just in the normal time frame, and here we're simply showing the components of the service policy that are providing protection, things that we talked about, like blocking that fingerprint, the IP reputation in there, and so forth. On this chart, the red squares are our regional edges, or REs. Some folks may, in prior years, might have called those POPs, but it's a much better, a preferred term nowadays to refer to those as a regional edge. And that's a specific distinction within F5 Distributed Cloud, as opposed to, say, a customer edge, a topic we could get into another call. In this, the bigger circles are the sources. The traffic volume is the flowing dots. If you go to the top right and click on Analytics there, that will pop out a dialog box with some quick reports on there about the specific attack. And you can actually go in and create rules right out of this dialog on the right without having to go into a configuration interface. You could create a rule to block the top ASN or that top TLS fingerprint right here by hitting that down arrow and creating that rule from there. So I spoke of the toolbox in the beginning. This is the toolbox in the F5 Distributed Cloud for security. These are all the various tools that we have available: rate limiting, reputation, API protections, WAAP, and so forth on here. The order of operations, I think, is also helpful to understand the layers of protection as well, and we flow left to right. And note the WAAP is way off to the right, and Jason, as you called out before, That is in part to protect its compute. Why let the WAF do all that heavy lifting? Let it provide its value where it's going to provide value.
Right. And to be clear, it does provide value even in this scenario. So yeah, if you hit your money slide, which is the next one.
Jumped it out there. And this shows us, what by what percentage which tool helped. So I'll go straight to the WAF. WAFs are, I love web application firewalls. That you first look at this, and it says 0.4%, like half a percentage point. Doesn't seem like a whole lot. But remember, there were tens, hundreds of thousands of requests coming through there that make up that 0.4%. That WAF was still doing quite a bit. And when we think about how many requests it was blocking, that's a lot of bad traffic that did not get through to our site.
Well, and if you think about the state actor or the organized crime actor, where they have the significant ability to layer their attacks. When you're talking about signal to noise ratio, if 99% of the traffic you're sending is just decoy, so that they can get the 1% of traffic through to and which is the actual attack, then that 0.4% starts to matter in your mind a little bit more, because you may look at this and say, well, why do I need a firewall? You still need the firewall. It's still doing a very valid purpose and a differentiated purpose. Can the firewall do a lot of the things in front of it? Sure. But, at a cost, right? And so you have purpose-built layered defense here, and it's fantastic. Yeah. So what I don't want the story here to be is that, whoa, I don't need additional service policies. I don't need the web app firewall. I don't need bot defense, because look at those percentages. They're so small. It's all important.
Yes. And I do want to just make sure it's clear that this slide is showing the security controls as it relates to this particular attack.
Correct.
And how they helped in by how much. Not every attack is different and will look different, but the concepts, I think, are going to carry over, not to just this attack, but subsequent attacks. But yeah, reducing the load on the WAF also, it reduces your number of false positives. As a security engineer, that's important. That's something that the security engineers have long been challenged to do. So we're glad to be able to help here.
Yep.
Last thing I would say is these tools all here are all in the recommended bundle. And if you want help with the recommended bundle, just reach out to your friendly neighborhood solutions engineer, and they'll be able to get you connected up with that.
Yeah, that's fantastic. Jack, thank you for sharing all of this. And now that we've been through this whole thing, for me, we talked about, it was the question I asked you at the beginning, was the web firewall being, 0.4% of this attack. It was like wow, look at all the things in distributed cloud in front of that that are doing some heavy lifting for this particular attack. And you're absolutely correct in that this is one attack, and every attack looks a little bit different. So, web app firewall on any given one might be 80%. I don't know. But on this one, it didn't carry as much of the water for sure as the services in front of it, but it still carried water that was important.
Yeah, this is exciting. The folks I've been speaking with about this topic have been very interested in it, and it's spawned a lot of conversations, to be honest. And likewise, us sitting here, right?
All right. Well, Jack, thank you so much for joining me and for sharing that real attack story for some unnamed F5 property.
Yep, and it's all up and running now, and that's good stuff. Thanks again for having me. And Jason, thanks for everything you and Aubrey and Boo and Leslie, the rest of the team do for DevCentral. Thank you.
Absolutely. Happy to do it, and happy to have such great partners like Jack for all the great work we do in community, whether it's online or in person. So thank you, Jack. Have a great day.